So, good evening, everybody. Priyadarshi, VP of Apps H2O. And we're here with a very esteemed panel here today to talk about the last mile of delivery in analytics projects. So, without further ado, why don't we start by first doing a round of introductions with all our great speakers. How about you first, Hassan?
Hello. Hi, everyone. My name is Hassan Amarwar. I'm a data scientist, work at Oracle.
I'm Seshu Guddanti. I'm a senior director of ad tech at Zynga.
Hi, I'm Prashant Agrawal. So we just founded a startup called ScoreData, but we have been building models as a services framework for the last few years. But now I've been kind of focusing on building a product for the enterprise. And before that, I have been at building machine learning architectures and frameworks at Yahoo and share this. And Hassan was part of my team for a while.
Hi, I'm Henri Dwyer. I work at Dataiku. We're actually a startup trying to help bridge the gap between creating data science workflows and putting them in production. And I work there helping our clients, actually make that last step.
And just for the folks in the audience, we're going to be touching multiple topics in this one. The panel is, of course, around the last mile of delivery, but specifically we're going to talk about just why is delivery so hard in the big bad world of analytics projects and ML. And perhaps when we talk about the last mile of delivery, do we need to come up with unique ways of combining the world and best practices of product delivery with perhaps the worlds of how we typically deliver analytics projects? So very excited to have this group here with me. So why don't we start with the question everybody wants to know. Why is delivery so hard? Why is delivering an analytics project so painful? Why does it make me lose sleep? Anyone on the panel?
I can start with that question. So basically, machine learning or data science projects is naturally different than other projects. So why is different? Because there are, first of all, the system becomes first than algorithm. What that means, in the production and when you work in the industry, so the machine learning product is not just machine learning assignment in academia. So in terms of the system, what I mean is how is the reliable the product, how fast it is more important than the accuracy. Usually, if you look at the academia project or Kaggle project, the accuracy is number one. But in the production level, machine learning, that is the second priority because look at the applications. For example, if you are in the finance, if you're building the trading system, automated trading system, you have to be very, very fast. You can't, wait until, the opportunity pass by. So that's one intrinsic problem. The second one is basically the system is so complex because there is no one can understand the system completely. When we talk about the large-scale industries, like in the LinkedIn, or like eBay, Amazon. So that's the second thing. And the third one is basically the system is changing, is the dynamic of the system. You can build something today is working, but tomorrow the dynamic of the system has been changed, but you have to be prepared for that. And then for the business, understanding is important because whatever we do optimization, first we need to do experimentation. And this experimentation is coming from the A/B testing, usually. So you have to understand why your algorithm is working or not working and describe it and to the business people to understand that. So that's why the nature of the problem is very difficult. So that's why. So that's my opinion.
So, in my opinion, there are two flavors of this problem. One of the sort of the flavor of the problem is a large amount of data. Once the model is developed, you want to score that for say 100 million of your customers, and then and you wanted to do a nightly job, then it's fairly intensive or compute intensive to sort of score all these customers very quickly, and this is kind of a challenge on the batch side of it. And the next sort of flavor of this is how do we solve the same scoring in a real-time model where people are expecting millisecond response. A couple of examples there are like if you are on the first page of the web and you did some activity, how can I customize the second page of the web? Or in my advertising world, that if I'm sending out an impression, there are multiple bids on that, and then all of them have to respond back with the bid in sense of milliseconds, actually, how much they want to pay for that impression. So those two are sort of the big problems in the last mile or the last millisecond of analytics projects, and that's probably the biggest challenge that infrastructure, models, and a combination of those two can solve, or even services could solve.
Yeah, and one thing I would like to add is, in general, the people that have the skills to build those models aren't necessarily the same people that have the skills to put it into production. So you can't always expect a data scientist who knows how to try all the different models and maybe iterate through and create something that works really well to have all the skills necessary to actually create that production level deployment to sort of meet all those criteria that you talked about, like low latency and things like that. So I think that's one of the things that adds to really having trouble doing that last step.
I'm going to add a few more things. One of the problems is the mismatch of expectations. So one of the, you start an analytics project and say, oh, this is going to change my business ROI or something. And it takes quite a bit of time, actually, to really understand the problem and really tying it with your business metrics. And people don't spend enough time ahead to really think through that problem and setting a proper timeline around it. It's not like you build a model and suddenly everything will work like a charm. It doesn't happen that way. So really taking the time and having the patience to go through it is an important step. And actually, that's where I think you will spending a lot more time solving that problem.
No, thank you. That's a fantastic overview. So if I might summarize, it's difficult and our lives are difficult because of the latency issue, the complexity issue, the dynamism of the end customer, the scale issue, the talent issue on people productionalizing versus building the models, and then simply doing due diligence around better managing the timelines of the projects and whatnot. So we know what the challenges are in delivering the last mile. What can we do? What best practices or what tricks have you learned delivering these kind of these engagements or projects or even product schedules around analytics that have made your lives easier? Like if you could give one word of wisdom to the future analytics delivery product manager or engagement manager of the future, what would be the one pearl of wisdom you would give them?
So my first, and then we have built models in our company and run into productions which handles like 10 billion bid requests a day. So first thing you want to start with start with a simple model. Every data scientist will jump and say, oh, I'm going to build this cool deep learning, this, that, but it'll take me 3 months to do it. Okay, that's a no. So you want to really start with a simple model and make sure that you go through the whole process of building the model to deploy into production. Nail that thing down. Then only you should go over to a more complex algorithm or something. And that's the first thing. And second thing is really making sure that the data scientists really spend time on looking at the data. Because I think the data which you get by just for the data processing, but doing all this feature engineering is a very critical part of the whole understanding data. And I think once you get those two ironed out, you'll go a long way. The last part which we did is how do we move the models into production faster? Moving them, how do you deploy the models in production? How do you log it? How do you log the score? How do you come back and make sure that the models is working as good as you expected? Not just the business outcome, but at a level of data scientist level. All those things you need to think about and make sure you need to change your applications and your systems to monitor that.
I mean, some of the things that we have done over the past is combination of two things. One is the combination, actually some of the aspects that he brought up, which is the combination of the team, having a data engineer in the mix, who knows how to bring the data together, who knows how to actually productionalize the model if it is built, and of course a data scientist, and not to build a very fancy model, but a simple model, and actually a business strategy person actually to solve the right problem. Are we solving the right problem, and are we going to get the right lift or ROI from this? So having the right combination of the team very upfront in the process is a first step in that. And of course, the second part of the equation is can we actually better the infrastructure that the company has, both in terms of software and hardware, to actually improve this, because the amount of data that we have, is so huge these days that you need to have a different computing paradigm sometimes to solve this problem.
If I answer this question with one word, I would say strategy. And think ahead before even you start the project. Even before the first mile, you need to think about that from every piece to the end of the delivery. Otherwise, if your strategy is wrong, so you're gonna stuck in somewhere that which is the real problem. You will face the real problems, and you have to go back, redesign, and then if you're not be careful, so you will hit different problems again. So having strategy is very important because as Prashant mentioned, having the team is very important. Having someone, that right person, understand this problem. So insight from the business problem is more important than just having the technology, because right now for each kind of problem that we are facing in this domain, so lots of people spend lots of time, acquire the knowledge. So how do you leverage this kind of knowledge, to solve your problem, in correct way? So that's very important. And then you think, okay, now I have my people, what kind of technology I need? You look at the business problem, is if your business is going to scale it up, so you have to think about that, such that make this architect so that can be easily scaled up. Otherwise, it's not going to work simply. So that's my suggestion for people that try to build up the system, machine learning system as a product.
Thank you. Very insightful. I heard two nuggets there that I found particularly interesting. There's almost an art form to creating this hybrid team, as you were indicating, Seshu, and there's almost you have to almost have this very strategic perspective even before you start delivering this project, right? If you don't define it early in advance, probably won't go very well. Now, to that mind, why don't we deep dive into a question that might be a hybrid of the old two responses? Let's talk about talent strategy. Is it harder to manage the people inside a data science team or an analytics delivery team or a ML delivery team than it is in a typical project? I mean, one of the jokes we often talk about is, let's draw a Venn diagram between millennials, eccentric people, and data scientists. How much is the intersection? Depending on who I'm talking to, the joke varies. But tell me about your experiences in managing different talent pools here. Did you have to modify your strategies when you were working with these really interesting hybrid teams here?
Sure. Would you like to go? Sure.
Yeah, so definitely getting the right skills in your team is critical, because for these kind of production level machine learning deployments, you have to combine a couple things, in particular infrastructure experts and data science experts, as well as people that will be able to write the code for those models to run in production. So definitely the problems I've been seeing a lot are getting the right people to sort of work together in the same environment, because if you end up having the data scientists write their whole pipeline in R, and then when you want to deploy that, if you have to spend the time to rewrite everything so that it can run on a Hadoop, that's going to create a lot of delays and increase the cost for your projects. So thinking about strategy first, what your deployment is going to look like, and then try to get the people that can work toward that goal immediately, starting from day one of the project.
I would say yes. People come from different background in data science domain. We have people that coming from statistics, from math, physics, and we have people coming from just the computer science background. So the data science is kind of intersection of these domains. So in order to have the right people, we would look at some not only the level of the intelligence of the person, but what kind of skills this person have to solve the given problems. Of course, having diverse people is good to have it the team. I don't like to have all my people coming from the computer science program. I would prefer someone coming from biology, someone from physics, math, because they look at the problem from different perspective. Having combination of those people working together, I think I have seen in the past it worked well. So there might be different level of the proficiency in terms of the writing the code or solving the math problems, but eventually they're going to converge at some point. If you could formulate and manage the team in the correct way. Yes.
So normally, in the past, what I've done is one thing I wanted to avoid is creating this the data science who say I build models and throws the model to the other side of the fence, and they say, okay, now implement the model and push it to production. That doesn't work very well. So what I have done in the past is try to hire people, data science people, who can really write code and look at from the end-to-end point of view. They not only do data analysis, build a model, even help write the production code, and then do the A/B testing themselves, look at the results, and tell me about it. They don't need to know everything. They will, of course, use some of their peers where they need help. But understanding the whole end-to-end is very critical. So that way, what you're building, what you're learning, you can go much faster than trying to have this separation of duty kind of thing. On the retention side, team side is a challenge. And what I found, there are a lot of data scientists, they always want to work on the school problems, right? And sometimes there are not enough cool problems. Sometimes you just have to do it, and it takes time sometimes to prove. For example, ad tech industry, we do conversion modeling. It takes time to build these things, prove it point, and keep iterating on it. You might spend 6 months doing that. So it's a challenge, but there's no easy solution.
I mean, sort of the, one of the challenges, it's a diverse teams, as everybody said, that's pretty given. And some of the problems that, we solve are actually complicated in the sense, for example, if you take a, conversion funnel that was brought up, you can actually start from, somebody clicked on, a website and then landed on your website. That's one level of optimization. You can say how many people actually started applying on for that, say, credit card application. That's second level. And you can take it nth level and then say how many people actually stayed with it for the last, 3 months before. So if you start optimizing the complexity, it's actually phenomenal. So you got to control the scope of what the analysis that you're trying to do, and actually have people with, strong domain expertise and the business expertise in the project mix, and with a kind of systemic thinking that this is not just one piece that I'm solving, but if I actually change this, there are many pieces that get impacted by that. So that's a kind of systemic thinking, and people with diverse skills is probably important.
That's great. Thank you. Great overview. And just to summarize then, so do a lot of thinking around creating the right kind of team, as you indicated. Work really hard in actually cultivating the culture clash, which leads to creativity. And then finally, even if you don't have a school book problem, nurture to create the kind of environment you need to keep people motivated in these kind of projects. So we live obviously in this age of specialization. And I like to tell people that, machine learning and analytics in the Valley is sort of this mini renaissance where increasingly you need, as you folks indicated, these end-to-end thinkers who can look across domains and work with people across domains, create that creative clash to solve these really interesting problems. How do you manage as part of the delivery lifecycle, particularly in these really short delivery life cycles and sprints sometimes, the desire to push people to say, get out of your comfort zone, and it's okay if you're a data engineer, you have to learn a little more about statistics. Okay, it's okay, you're a statistician, you need to learn a little more about deployment. How have you, in your careers, pushed people on your teams to get out of their comfort zone and be more like these Renaissance thinkers?
I mean, definitely that's a good point. A lot of people today talk about like the unicorn data scientist that can do everything from creating his own Hadoop cluster to creating the models and everything like that. And that's not completely realistic, but definitely one of the things that has been really important is to kind of push people to expand their knowledge and do more of those different steps. That way it'll help you a lot when you try to eventually deploy those things, because the people building the models are already thinking about the next steps, especially if they have to participate in those and actually getting it to all work.
One thing I would encourage the kind of participate in the communities and also use the open sources. So also going to the conferences to be exposed to different kind of problems and different kind of techniques that people are using and tools. The tools also is very important because once people start using it and then they see there is a value in the tool, so they keep doing it, they keep learning it. Otherwise, if a tool is very difficult to work with, well, of course, the people won't participate, So, we are in the age that we have the great open sources tools available for us. It's kind of, dumb if we don't use it, So that's the, some companies, still, using the in-house software development or the internal tools. That makes sense if it is a kind of, secret secret for them. But if it is not at that level, so why not using the available sources and then assign people to different projects and see that how far they can go, and then at different levels they expose to the different phase of the project, and maybe after a couple iterations they are very comfortable from end to end. In that case you have the great data scientist plus developer together, one person. So that's very important actually to having them. Yeah.
I mean, one other way of looking at it is to constantly sort of challenge, where the bottleneck of the process was, and then pinpoint on that bottleneck, and then can we innovate in that particular bottleneck. If the data scientist or the modeling part or the data moving part was the biggest challenge in particular, delivery, then what are the tools that we can have? What are the skills of people that we can actually get to that fix? And then so that the next iteration of this whole process would be better. And then, if we keep doing it, then hopefully, we come to a stage where the whole process should work much more smoothly. And keep a focus on what the bottleneck of your company is.
So normally I look for two things. One is I focus on hiring. When you really hire people, you want to hire people who can do attitude, right? When you're like in a startup, if you need to fix a laptop or something, you don't want to say, I am not. It needs to be there. Whatever it needs to be done, it needs to be done, right? And the second thing is you want to sell a big picture to everyone. It's why is important for you to help out, and hey, you want to do a little bit statistics. Okay, you'll fail a few times, but this is good for you in the future. Or somebody who is doing a data science, hey, why don't you learn a little bit of how it works really in the production system? You'll learn a little bit. If you can sell that thing, I think that's going a long way, because I think those two elements will help you cross-train each other and make sure that your team is effective in the long run.
Great, thank you very much. I recently got into a debate with a very young data scientist, very gifted young woman, and we talked about is there in fact a converse opinion around whether or not specialization is a good thing in our business, right? So we've obviously talked about hybrid teams, smashing up different people from different cultures and different behaviors to create creativity and solving unique problems. And she was very much of the same mindset. She said, absolutely, I want to be a generalist. I want to be a data scientist for every industry. But then I had a conversation with another much more seasoned, older gentleman who's been doing data science for a different product, let's say. And he is very much of the opinion that no, we need to create a generation of data scientists and delivery teams focused just on verticals. So we should create the next generation data science team for financial services or banking or for fraud or for supply chain, etc. What are your thoughts on that? Do you think it at some point makes sense to not only think about these horizontal players, but also these really verticalized delivery players in our business?
I mean, if you think about even within financial services, for example, what happens is initially when data scientists as a scarce commodity, you keep them centralized and generalized. That means that the data scientist can be used across multiple projects. But as the community builds, and then there's say 10 people, and you have a instead of scarcity, you have a plenty, then what happens? Then to differentiate themselves, they become specialized in risk modeling, maybe in trading systems. And then, so it all depends on, supply and demand kind of a model. But, most of the people would start, as generalized and then would become specialists, depending upon, where they are in their career.
That's great. So it's basically letting the data scientists find which industry they're more passionate about and then eventually letting them focus on the models there. Very interesting.
Yeah, I think it's a natural flow rather than a well-designed plan, right? And most of the time, somebody say I picked up Java versus C++ or Python, right? Once you get interested, you just kind of go with the flow. So I think more or less you make sure that you train your data scientists or overall have the basic, and then people will see what problems they're facing, and I think people will be able to migrate from one vertical to another vertical without too much difficulty. It's not that you're going to work in a single vertical for the next 30 years, right? That hasn't happened yet. So,
yeah, I would say that some of the great ideas that have come out recently are from people that applied ideas that were in one sector to another sector. So I would say it's also important to kind of keep that mobility and keep the ideas flowing between, risk modeling or if you want to apply that same thing in manufacturing or something like that, you need to sort of still have that flexibility for people to change verticals.
Yeah, I would agree with everyone. Actually, it's the level of the people, actually. So at the senior level, when you look at the data scientist, he or she should be very comfortable when you pull him from one vertical to another vertical. So breadth of knowledge is very important in this domain because lots of the commonality in the problems in different domains can be solved with different techniques that looks like different, but in core it's the same. So you need to have a basic understanding about the theory. So otherwise you won't understand what you're doing. And being specialized is inevitable in the future because look at the number of the papers that has been published for deep learning. Okay, so in the past, this is the state of the art, and people working very hard on that. So if you want to develop the state of the art algorithm, deep learning algorithm, you have to be in the field, very specialized on that. But on the other hand, if you cannot heard about GBM or logistic regression, that doesn't make sense because you have to know all of them, and then at least some applications in the different industries. How the people solve that kind of problem, like in finance, what is the risk modeling means, for example, or in the healthcare, or in the image processing or speech processing. There are lots of fields that using the machine learning techniques, but I think is exposing to the general theory is very important, but being specialized is good also, is a good combination of that. So
that's great. Thank you very much. And so as long as we're talking about this cross-pollination of different domains and letting people find what they're passionate about and specializing and then maybe coming back and mashing up ideas and algorithms from different spaces, I want you to talk perhaps to me a bit about the ultimate cross-pollination in our business, which is perhaps the thinking and the domain and best practices of product delivery versus analytics projects delivery, right? I mean, I see sort of this great panel that's a mixture of people who've done some delivery, some lots of delivery, and then some product people here as well. Do you think that there's a converging world between the way we've typically thought of ourselves as product managers coming to the world of delivering or servicing analytics projects? Do we need to start maybe getting comfortable with the fact that a product manager might also be an analytics manager on a customer or a client and vice versa? I mean, we certainly see something like that happening with Palantir. Do you think that's something that's going to happen and is indicative of the broader industry trend?
So the way, in my opinion, so there are two different directions. I mean, the product, if it is a fully canned product, that means that it can actually specialize. It actually solves problem A, B, C in a very specific manner and a black box kind of a model. And then, of course, that can be sort of used on a generic way. So of course you need a set of services model where you are generalizing the solution, and they could use for a broad base, there's services on top of it to put together, or there could be kind of an hybrid model where it's not completely productized, but you have kind of tools or tools plus a little bit of a knowledge, and with open sources these days you can actually put together an application or a product together very quickly. So that's a kind of the evolving model where there is services plus there is products, but you can actually put them together quickly.
So this is, I think, the service. Why do you need services a lot more is because we don't have a good amount of tools, and if we have tools, they're a little bit complex to manage, right? So what I see is the next 5 years, so a lot of these tools are really coming into now in this area where it's making things easy. Right? Now if you look at S2O now, you can build models, algorithms very quickly. You don't need to know the whole math behind it. You just use the platform, right? There are a whole bunch of tools coming out. So I think in the next 4 or 5 years, you'll see a lot more tools coming into which will make your life a little more easier. And now more products will be, 80% will be a product and 20% maybe you need to spend on the services front. That'll be the right model for the long-term success of this. Because I think if you just rely on services framework, it doesn't allow you to scale, and it doesn't allow you to, beyond Bay Area, I think, there are not too many data scientists in Kansas City or somewhere. So how do you scale businesses which are in the remote places? So you need to build products to make that easy to scale.
Spoken like a true product owner. So I love the fact that we had two completely different opinions, one from someone with a very strong services background and one with someone with a very strong product background, but we'll leave the debate open. How about that? But one of the things that I personally love about our space is we have people, particularly, I know at Zynga, Seshu, you actually have ship dates for models and how to productionalize them, right? You almost think of it as shipping a product for the broader company over there. So tell us a bit about that. You very much Zynga is doing things like shipping a product, except actually shipping an algorithm to the larger organization. I mean, tell us a bit about maybe, and I'll open this to the entire panel. Tell me about your favorite horror story when it comes to shipping an algorithm and productionalizing it. You want to start, Seshu?
Yeah, I mean, broadly, the way in Zynga or else in my past, the way we have managed analytic projects is actually like a product. I mean, even though it's not really a full-fledged product, or the end customer is probably transparent to it. He or she may not even see the product and touch and feel it. But so of course with that comes up with a model where there is a product manager, and then there's of course all the team that we talked about, the data scientists. So one of the horror stories is people underestimate the size of the data, and when people are like scoring on the last day before, we want to score 100 million customers, and then we're trying to pull this data onto one server to score, all things go wrong. There's no disk space on that server. There is no bandwidth is not enough between these two data centers where we're running the model versus where the data is stored, and so some people have actually babysit the whole scoring overnight or a couple of nights to actually run this into production. So I'm sure people have this similar experience.
I would talk about my experience. Before I joined Oracle, I was with eBay. So eBay basically is a multi-billion-dollar business, and the search engine is the core of the system. Okay, so and the machine learning and continuously shipping is the very, very, the important piece of the work that data scientists are working. So basically, I don't have the horror story to tell, but I can tell in order to prevent that, there are mechanisms to prevent that happens. Because building the model is just the first step. So the fun begins after you build the model. You have to put it into production and how to utilize it and monetize it. So the whole team working, on for example, the QA the output of the model before shipping to the production. Everyone should look at the model itself and the output. And if there is a discrepancies or something is wrong, we catch first. And then the code is translated to the language that we use it in the search engine, like in eBay is a C++. So it has to be compatible, it has to be compiled, no error, and then QA people in the search engine back end also validate the model. And then everything is good, we ship it to the web servers, okay? And then there is a plan to A/B test it. So without A/B testing, we're not gonna roll out to the whole production. So there are there are steps even for before the A/B testing, and once the A/B testing is coming up, then there are like 3 days before the actual test is going to the production, because people wants to see that everything is going smoothly, and then after that, real measurement begins after 3 days. So, and then we start collect the data, analyze the data, and also there is a monitoring system. So without the monitoring system, you don't know if the machine learning output is valid or not. Always the algorithm is going to generate the numbers, okay? So how do you know that the number is good number or bad number? So there are, in order to prevent that can happen, there are lots of mechanisms in the large scale the business. So that's my experience from shipping the machine learning product in the best way.
Great, thank you very much. We are almost out of time, so I'm just going to summarize that by saying, let's avoid these horror stories with better governance, preventive controls, throwing lots of bodies at them, which is a classic services way of doing things, and of course, my favorite, let's come up with better tools, better products, and let's automate some of this, which is, of course, our philosophy here at this company. So with that said and done, thank you to this amazing panel, amazing conversation. Round of applause, and we'll open up to questions.
I'd love to hear, before you get to the last mile, you should also talk about what you did in the first mile, what you do, especially in data science projects. The first mile treatment determines a lot about, the quality of the last mile. So if you could speak a little bit about that.
I think that's a great question, so I can take that. As I said, before even you start, you have to think about the architecture. So what is important, how do you architect your system? If, for example, I would put it in this way, what's the best architect for the machine learning products? So basically what you need to do is look at how you get your data first. The data pipeline and the modeling pipeline is very important piece. If the data is coming, streaming, so there are kind of, multiple architects available. Like I would say for example, Lambda architect, people used it in the LinkedIn, and then there is a problem, one problem with that. You have to change the code in 2 places, for example. So people come up with the Kappa architect, for example. So if you have the data, is the streaming data is coming, so you need to think about that first, that what kind of architect you're gonna get first, and then what is your, for example, data storage. So data can be, structured data, unstructured data, and how is your data flow is going to go, data pipeline. So once you figure out what kind of system you will use, then it's the modeling pipeline is important, which is probably you would use one of the the best, which I would give the credit to H2O, or sparkling water, for example. So, and then how to deliver it to the production. So I would say, like, right now, people, we have heard the talks that the people using the REST API, for example. So the modules are loosely coupled. So then you have the more flexibility to change your model, to change your data, to change your the data pipeline, and then you have more flexibility for the last mile delivery. So that's my opinion on that.
Yeah, and one thing I would add to the first mile is actually really thinking about what is your data, where does it come from, and carefully considering what kind of business uses you could get out of it. And I would say that instead of really thinking about that as the first mile, that's like the first 10 miles, because that's going to really determine all of the rest. And I would say that's where you want to really spend a lot of time, is really understanding your data and the questions that you want to ask of it, and that will determine all the rest.
Yeah. In addition to that, sometimes you need to figure out how do you make sure that what you're doing is a success, right? Sometimes do you have the response information, or sometimes you have to instrument certain things to get that information. So you need to think about that, because if you want that little bit of information, you may have to talk to different teams to say, hey, you got to instrument this particular thing for me to really validate what I'm doing. So really thinking through exactly understanding data, to really think how use cases, to figuring out how do I make sure that I can validate that this use case, what I built, is going to work, is the first 10 miles.
I've had a lot of questions and discussion about how hard it is and the horror stories. I'd like to turn the tables a bit and ask you about your favorite, your best experience, and your future ideal job.
So I think I had my own share of horror stories. We'll skip that. So best experience has been the way if I can see a problem where I can build models and test quickly, is my best story. Because I'm not looking forward to say, hey, I'm going to crank this super duper algorithm, and the way I would like to design my system and the way I design my engineering team is to make sure that I can test this idea much faster. That's the only way. Whether I'm getting the data faster, I'm building the model faster, whether I'm getting this experimentation with A/B results faster. If you do that, then you will be able to evolve with your system much faster. My idea will be to build, I think what I'm doing, we just started a startup, so building a platform, machine learning platform for enterprises, a little more easy to manage, and something fun along the way.
So my favorite one was putting together systems, all the way. Analytics could be something that could be on an interaction when a customer comes onto a website, does some activity, and then you're able to send like a quick response to the customers, and actually customer responds to that, and then you actually so integrating that could be like maybe 5, 6, 7 systems together, and making that happen. And that's like the sort of the joy of the whole thing, of putting them together. And then the dream is maybe to productize it.
My favorite one was the last year that I was at Share This. We were working together, and I built a system with H2O. So that was amazing, because the first time that I was exposed to the H2O and I installed in my laptop in 5 minutes, and I was able to get my model up and running in half an hour. So it was unbelievable for me that someone could create such software that works smoothly. So that, because of that, I went to see the people that created the H2O. So my story began with that. So that's my favorite, machine learning experience, because I've been in the field of, almost for 20 years, but I haven't seen such a tool that is working very well. And my ideal job is the job is I'm currently doing. That's my favorite. I'm gonna continue that, maybe in different levels. So I love my job. So.
Yeah, my favorite experience was when, actually getting a production deployment used and seeing it be successful and actually producing results. And when you manage to do that through all the problems that we talked about here, it's actually a pretty satisfying experience.
I love that question, by the way, because it helped us on an amazing note. And for that matter, I'd love to thank once again this amazing panel. You were the last mile of delivery between us and drinks that await us tonight. So thank you very much. And once again, thanks very much.